My name is Durga Rao, sir.
Okay. Okay,
Uh,
Durgarao, tell me about yourself. Let me know briefly.
yes, sir. Yes, sir. I have recently finished my physical design course in Marvin Silicon from Marvin Silicon in physical design. I have done my Bachelor of Engineering in Electronics and Communication from Raimak Engineering College, Ballari. I have
Okay.
completed my PUC from YJR PU College, Gangavati, and I have done my schooling from Tejasha English Medium High School, Gangavati. Coming to my projects, I have done router 1 cross 3, which is related to 32 nanometer technology. And I have done my, and I have run RISC V32, which is the 32 nanometer technology. And the Raven SOC, which is information about the creation of art macro. And this is about me.
Okay. So you said all of these projects, right? These are all related to the PD?
Yeah, yes, sir.
Okay. So tell me about your engineering, that is your bachelor's project.
Uh, yes, sir. And in during engineering, I have done multiple bank accounts using single ATM card using RFID technology.
It's already existing, right?
Yes, which means different bank accounts will be included in the same single ATM card, sir.
That still exists. That's what Google Pay is doing, right? Tap and pay. What do you have? You can get a card for it.
Yeah. Yes, sir.
Fine. Okay.
Okay.
So what made you to choose the VLSI?
Sir, from starting, I was more interested in electronics and communication.
Hmm.
So I took during engineering, and later I want to enter to the EC field.
Hmm.
Then I know about the VLS and the capacitor resistor, and later I'm interested to how they will place billions of transistors on a single chip. And I like that it is like interesting to me, sir.
Hmm. So, can you tell me how many millions of transistors are getting placed in nanometer technology, whatever the nanometer technology, just a reference?
Like in billions, sir, like 10 billion.
No, that is only. Tell me that technology node and uh, how many transistors are getting placed there.
Uh, 5 nanometer technology.
In 5 nanometer, how many transistors?
Like 10 billion or more than 10 million.
10 billion.
Yes, sir.
Sure.
It's more than million, I know, sir. From million to
That is what. Okay, we'll take one thing. You tell a particular nanometer node and how many transistors are present, be it million, trillion. You name it and tell me properly. You name a technology node and tell the transistors in it.
uh, sir, I don't have any ideas. Just I want.
When you are interested in VLSI, you don't have an idea how.
Just I know that there are types in large scale industry, very large scale, medium scale industry. In small scale industry, we place from 1,000 to 10,000, and in medium scale industry from 1,000 to more than
Not like that.
10,000.
It's not like that. It's not like that. It's not like industry wise. It's all about the chipset and technology wise, right?
Okay.
So it's now VLSI has everything included. VLSI means complete. Don't have
Okay.
any bifurcations.
Yes.
Mm.
And this is
So
my first interview, sir, so I was not that accurate to
okay,
speak
okay,
confidently.
fine. So which course did you do?
Physical designs.
Okay, now brief me what you did about your physical design course and brief me about it. What you all did in Maven Silicon.
Yes, sir. The first of all, the physical design means it is a process of transforming the circuit description into physical layout by following various steps like partitioning, floor planning, power planning, placement, clock tree synthesis, and the timing closure which is related to STA, and the sign off. First, we are going to, in the partitioning, we are separating the blocks to analyze and to do the work easy form. We are dividing into sub blocks. And next, coming to the floor planning, we are determining the size and shape of the core, and placing the IO pad site, and creating IO pad sites for IO pad placement, and creating standard cell sites for standard cell placement. And we are adding physical only cells, and we are doing the core utilization. And coming to the power planning, here we are creating the power and ground to the each and every standard cell and macros during the power planning. And after the power planning, we are going to the placement. In the placement, we are going to place the cells. Here we are going to do the steps like global placement, course placement, and detailed placement. In the course placement, the cells from the origin will placed in the core, but not in the exact placement grid. But after the in detailed placement, the cells are placed in the without any overlapping. After the in the and we have the hard blockage and soft blockage. In the hard blockage, there is no chance to place any in the hard blockage, there is no chance to place any cells in the preferred location. Coming to the soft location, in the soft blockage, we can place like only buffers. And
So
coming
what I was asking is, I just asked you to brief. I didn't ask you to explain what you did, right? So there's a small gap between a briefing and explaining. So
Okay.
briefing should not hardly cross more than 2-3 minutes. Explaining can take 30 minutes, right?
Okay.
So understand
Yes.
the words. Brief means what? I'm asking what you did,
Okay.
right? I didn't ask you explain everything, right?
Yes, sir.
Now brief me again what you did.
Sir, in Marvin Silicon, uh, I have studied about the physical design, and what are the related topics about physical design, like from synthesis to the GDS, and how the CMOS works, and that's
Okay. So you did a project, right? What nanometer project was it?
32 nanometers.
32. Fine. Okay. So in 32 nm, which tool did you use to do it?
I used for synthesis. I used design compiler, sir.
Okay.
For from floor planning to for PD, I used that the ICC2 tools.
Okay. Then.
And for RC, for physical verification, I have done with used caliber tool, sir.
Okay.
Uh, for RC extraction, I used star RC.
Fine. Now we'll start with physical design. Now tell me what are the basic things that need to be taken care while doing the floor plan so that you can get a better result.
To get better result, sir, you are asking what is the goal of floor planning, or?
Yeah, that is what you have to do to so in floor plan stage, or what things you have to take care in floor plan so that your results will be better in the next stages.
Yes, sir. Placing them by doing flyline analysis, placing the macros to the related whether the macros are connected to the cells, or placing near to reduce the wire length, and also uh, minimizing the wire length and the area.
Repeat it again.
Minimizing the wire lengths nets,
No, no. So minimizing the wire length nets, what you will do?
which helps to not cause any congestion.
How will you minimize the wire length net and all? How will you do it?
Uh, with the help of flyline analysis, we know the connectivity informations.
Okay, that's a
With the
logical connectivity, not
Yes,
actual connectivity, right?
yes, logical connectivity information. So with the help of logical and connectivity information, we can place the cells nearer it, sir.
Okay.
Uh,
From that,
from that, there will be no long wire length, sir, which cause delays.
so there will be no longer wireless, which will cause delays.
Yes,
Okay.
sir.
Okay. So that means you are perfect at the initial stage only. So this will not cause any longer wire lengths or nothing like that.
Not like that, sir. We are using the tool to.
Fine. But why? But you only said right, it will be no longer net length will be there, but and all, and it will be clean. So you are expecting it to be clean and neat, right?
But we are placing only the macros, no, sir.
Okay.
But what about the standard cells and
Hmm.
the standard cells are placed during the placement?
Hmm. Okay.
Uh, in the during floor planning only, we used to place some blockages where there
Hmm.
is no. We don't want to place the standard cells
Okay.
and some keep out margins around the macros and some
Hmm.
halos
Hmm.
so that there is no placement of standard cells during the
Hmm.
placement stage.
Okay. Then.
And the correct exact placement of IO pads
Hmm. Where you will place them?
in the boundary regions, sir. And it is done by the top level people.
Hmm. So you'll never place your pins or ports.
What's
You don't have an idea about placement of pins and ports.
No, sir, but it is some critical. So the top level people will be used to do that work.
So that is what I'm asking. Will you do it? You know to place a pins and ports or not?
Yes, sir.
You know.
I know, but the tool will automate this.
That's a script you are sourcing. That's it. But you
Yes,
need to know how to place them manually, right?
yes.
How can you place them then? How do you do that?
By using initialized floor plan.
That will source all the. So when you do a initialized floor plan, what will happen?
The boundary area is created.
How it is getting created?
We are giving the core ratio, size, shape.
So where will it be?
What's
Where will that be? Your core area size and all.
core area size and all in the left files.
Which file?
Left
It will be in the left.
left physical information we will get from the left files.
So when is this the physical information defined? Where is this defined? In left only. So you can get a left at the floor plan stage itself.
It
Okay,
is getting
tell me the inputs for your floor plan.
inputs for the floor plan are netlist,
Hmm.
SDC file,
Hmm.
library file,
Okay.
lib file, left file.
Left also.
Yes,
Sure.
yes, sir.
Okay. Fine.
And the technology file
Okay.
and some scan chain information, DFT.
No. Okay. So now tell me how will these work in your floor plan? So what will you do with your netlist? What will you do with your SDC design constraints? What all this will impact in your floor plan, or how will these play a role in your floor plan?
Sir, we get from the lib file we get some the timing information and the functionality and the power information of
What
the
kind of timing
macros
information you'll get?
from the input delay, output delay,
Output delay,
maximum
input delay of what?
cells, sir, cells, macros,
Which cells, which macros?
standard cells,
Hmm.
macros,
Hmm.
hard macro, soft macros.
Okay. What do you mean by soft macro?
Uh, the soft macros which we can see both functionality and timing informations.
Okay.
But in hard macro we can see only the timing information. We can't able to see the functionality and
One
what are the
example
gates
for your soft macro.
for soft macro. Sir, I know that PLL, RAM, ROM, RAM.
Okay. You can see the functionality of RAM.
I don't know whether it is a hard macro or soft.
That is what I'm asking. One example for your soft macro.
I don't know, sir.
Fine, go ahead. So library you said, timing information you said. Then
By using constraints, sir, what are the constraints? And in the constraints, we can see where are the area we not to place and like blockages, and those all defined in the SDC file, sir. And in the technology file, we can see the layers information.
Okay.
Layers in left file, we can see the pin name, pin location, and the pin layer and direction of the pin.
So you are saying that everything will left has this pin etc. and all already
Yes,
defined.
yes, sir.
Hmm?
Yes, sir.
So you don't need to do anything. Then what's the use of you? If I source all of this to a tool and I'll ask the AI to prompt it and source it and run it, AI will do it. Why should I hire you?
Sir, we need to properly guide it, sir. For macros, we need to place manually if there are less macros.
Fine, I'll hire someone for only macro placement. I'll ask him to come in the morning, place the macro, and leave in the evening. That's done.
And first, we need to check about the sanity checks, sir. Whether these
That
all are.
okay. How will you do the sanity checks?
Sir, the sanity checks are done before floor planning. Like for design checks are done. For design, the checks are done. For SDC checks done. If for SDC, if there are any unconstrained paths, by giving report unconstrained, we can check whether there are any unconstrained paths.
What is unconstrained path? What do you mean by them?
Unconstrained, sir, like for without any we need to define, sir, but we not defined in the SDC file.
Sorry, repeat it again.
We need to define in the SDC file, sir, but we are not defined that one.
Why? Why you
Like
haven't now defined?
like multi-cycle and
Yeah, tell me.
timing
What
exception.
is? Why do you do that?
What's it?
Why do you define? Why do you? Why haven't you defined it? And why you said multi-second and fall, multi-second false path, right? Why? What are they? And why are they necessary?
Sir, multiple cycle path, it takes more than one cycle, sir.
That I know. Why?
Intention.
Why you need multi-cycle path?
Sir, like in 2-bit comparator, like some things it takes more than one cycle. If if the storage is full, it takes some time to come.
Okay, go ahead. Correct. Yes, telling correct. Explain it more.
Uh, Instead of using like 4-bit, if you are using 2-bit, then there is some need of extra one cycle, sir. Uh, and in the false path, the it is the longest path, but which is we not required, sir.
Okay, so what will you do for this? You'll set this as a
Timing
multi-site.
exceptions we place in the time.
So how are these being going to be addressed?
Some techniques we will use, sir, like path sensitization technique.
What else then?
Path sensitization technique and
Fine, go ahead. Skip it. Go ahead. Okay, multi-cycle path, false path. Okay, this we got to know. Timing
yes,
exceptions we got to know. SDC we got to know. Sanity checks we will come back to sanity checks. Okay, continue with sanity checks.
yes, sir. Sanity checks we are doing for SDC whether the clock is given to the all the flip flops to the clock pin of all flip flops. In the SDC, and there are any like floating nets, undriven input ports, unloaded output ports. Whether these checks are done in the SDC checks, sir.
Okay, then.
SDC checks and the design checks we are going to do, and what we are doing.
Then what else? Give you a scenario. So what has happened is that I've done a flow plan, but
Yes.
one of the macro which I have to place together, I've placed it at the other end of it.
Yes.
So now I am seeing a very longest path that is being
Yes.
connected between that macro to one standard cell that is sitting at the other end. Only one connection. That is one
Yes.
fan out, because this macro has only one pin. That's on one pin, one input and one output pin. The other cell is sitting at the other end. Okay. So now
Yes.
we
Sir.
consider left bottom and right top. Okay.
Yes. Sir.
So all the groups are sitting at the right top, but one macro I placed at the left bottom
Yes.
corner.
Yes. Sir.
So now I want to make sure that there is a long net connection between these two. After routing, we can see this. So what would be your approach if you are going for the second iteration to do it in the floor plan?
Floor plan. Sir, by using the flyline analysis, we can see we can.
Yes, that has done. I tried it, but it didn't go. So I have already moved it now. Now what can you do to make it correct in the next iteration?
Sir, manually I can change the position.
Manually, you are going to change the position of what?
Macros.
So you are in the next iteration, you are going to change the macro position again.
Yes. Sir.
Okay, fine. After that, where are you going to place them? Where are you we are going to change the position to it? Like where you are going to place it?
To nearer to the connectivity cell.
Okay, so if you move that, won't there be any disturbance between the present existing cells there?
Yes, sir. It will be some delay information. So by doing incremental optimization.
Okay, fine. Okay, then I have aborted two macros which are off on the same, which are having the pins in between them. So what issues may I get here?
What, sir?
I have aborted two macros,
Yes, sir.
and the abutted side is having pins for both the macros. What
Yes, sir.
issues might I face during these placement, or what issues I might face due to this type of macro placement?
Sir, it may cause like a IR effect.
Okay.
IR effect, and because in between we need to propagate some power and ground signals,
Mhm.
and it may cause some signals near the placing of near signals. It may cause crosstalk,
Okay.
uh, and uh, and the signal may goes to the metastability state.
Why?
Uh, because the supply voltage it will be less, sir.
Mhm.
So the macro doesn't know, it takes whether high logic high or logic low.
Okay.
It goes to the metastability stage, and some conjunctions may occur,
Mhm. Then.
and some setup violations, hold violations.
Okay. So what would be the best approach to resolve these?
We can flip the macros to the pins to the other ends,
Okay.
and we can abute the non-pin side together, sir.
Okay. Fine.
Uh,
Fine. Okay. Now I have my macro. I'll just tell you the dimension. So the width of the macro is 700 micron.
yes, sir.
Height of the macro is to 300 micron. Consider. Okay.
Yes, sir.
So in this, the ports are all on the right side of the dimension. I mean, right side of the macro of the floor plan area. That is the size area.
Yes, sir.
So, what challenges I might face with respect to the timing in this design? So,
Setup
it's
violations.
basically a rectangle block.
Yes.
So, what challenges I might face in the floor plan stage? I mean, with respect to the timing in this block, in this rectangle. 700, the width is 700, height is 400. 300, you consider.
Yes, sir.
Or 400 by 800, exact triangle. 800
Yes,
is
sir.
the width and 400 is the height. So what
Yes, sir.
challenges with respect to the timing I might face during in these type of blocks?
It may cause like setup violations, sir.
How?
The signal will come late to the cell.
How? How can it come late? Justify.
Sir, the connectivity pins are long, far away, or
See, you take a paper and pen, draw a rectangle. Meter, left to right,
yes,
top to
sir.
bottom is 8 centimeter. Draw a rectangle.
Yes, sir.
Now tell me, how does it look?
Rectangle.
Okay. On the right side at the center, right side, that
Yes,
is
sir.
on the right edge, you have the pins placed.
Yes, sir.
Now tell me what challenges I might face in this block with respect to the timing.
Sir, it may cause congestion, sir, because the signal should be come to make a round to come near the pins. If there are left side of the if the connectivity pins are, if the connectivity cells are the left of the cell,
Left of the,
left of our cells.
I'll flip it. I'll flip and make the pins on the right side now, all facing towards the core. Okay, so fine. We'll go to the placement stage now. Okay, now you are
Yes.
seeing a particular area being congested. Means you are seeing a congestion hotspot there. So, what do you mean by congestion hotspot, and what are the techniques you would use to reduce this congestion hotspot there?
Sir, conjunction means the if the required routing resources are less than uh, the required routing resources are required routing resources are more less than the present routing resources.
Okay, so what does that do?
Um, so for the wires may it may cause conjunctions. The congested like suppose like we have four routing resources and we have we need five routing resources, so then we may cause congestion, sir.
How many congestions? What congestion? How?
Sir, I know that by doing refine placement we can reduce the congestion.
Huh?
Refine placement.
Refine placement. Okay, this has been done now. After refine placement, I'm seeing a congestion. The
Again,
block is area critical, so I don't have much space. So there is no refine placement happened due to the tool by the tool because it couldn't move much. So now
yes,
I'm
sir.
still seeing a congestion.
If not by going to the floor plan and changing the size or like constraints.
I can't do that. Block is fixed. It's the chipset is going to be on a wearable device. You're a smartwatch, so I can't change the size of the chip.
By doing iterations, we can't reduce the congestion.
You can't. You sure about it? So how? What causes the congestion to happen?
Placing the cells nearer.
So what's the goal to reduce the congestion? Your cells has to be placed far, right?
Yes, sir. Yes, sir.
So for what you can do so that these cells get placed far?
By congestion drive placements.
Congestion?
Congestion driven placement.
Congestion driven placement means what?
Uh, it indicates with the what may cause the injection congestion and how can we reduce congestion it takes and for that it will do the placement, sir.
That is what does it do? Have you ever
It may
opened the script when you are doing a placement? So you
it's
source a script right for the placement.
yes,
Have you
sir.
read it? What command it is going to use?
It spreads the cells, sir.
How? Have you gone through the log? How it spreads the cells? What command it uses? Your cells are getting placed closer. You need to
Yes.
spread them. So what you
Yes.
can do, or your cell needs to place further. So what we can do? You have to start our placement again. So with what
Place
settings you
out.
can do a placement again?
Place out.
Place out won't work, man. See, when you do a placement, placement will work, place out will work, refine place will work, everything will work in it. But even
Yes.
after doing that, still you are seeing means what you have to do? You have to spread your pins. Sorry, spread your cells, right?
Yes,
How
sir.
can you do it? Heard about cell padding?
What, sir?
Heard about
Cell?
cell padding?
Yes, sir. I heard that word, cell pad.
So what do you do with cell padding then? So what does cell padding do?
Cell.
This is where your one step in your design will change the whole design. If you know these techniques, use it at the
Yes.
placement stage. If you are able to resolve the congestion, we can play with the games later. You don't need to
Yes.
worry much about it, right? In the route stage. Otherwise,
Yes.
you do 10,000 iterations, it will be the same. You need to
Yes.
know if you are using a command, what does it do? You need to know, right?
Yes.
If you are using a command, you need to know what does that command do. Refine place, place op, place design, everything.
Okay, sir.
Fine. Now we'll go to the CTS then. Okay. Now you tell
Yes.
me what type of clock tree did you build in your design?
Uh, H trees.
Which tree you built?
Sir, I asked them about what is. They said that after the placement of the one shape, it after the like after completing of some routing, it will change the shape. They said, sir. So I don't have that clarity about what type of shape they create.
Shape. See,
I
shape
know
doesn't
that.
matter, right? So how does H tree work? There will be one cell, one buffer at the center, the other
Yes.
buffer at the top. Other two buffers that are branched from the center point, and
Yes.
on the left and on the right side. So there are four buffers going there. Let them get placed top, bottom, left, right, anywhere. But the shape where they are driving is like a H only, right? It
Yes.
is driving totally
H
four cells.
tree.
Let it change. The schematic tree schematic remains the same, right?
Ah, yes.
If you are going for pyramid, one will drive two, two will drive four, four will drive eight. So for this pyramid, it might place anywhere. But if it is driving means it is that is pyramid.
Okay, sir.
This is H tree. So you have to tell which one it is. Fine. Okay. Now tell me what do you mean by local skew? What do you mean by global skew?
The skew occurs between related flip-flop is local skews. The skew which occurs between unrelated flip-flops is global skews.
Unrelated means what? The skew
Uh,
between first and
s-
third can be global.
like different different clock.
Different clock.
Yes.
Sure.
Local means the side by side flip-flops
Side by side means what?
that which has connectivity information between two cells.
So what do you call both of them? There'll be a name for both the flip flops.
Related flip-flops.
Hmm?
Related ones.
How are they related?
They are sharing the signals,
Which signal?
clock signals.
Clock signal.
Yes, sir.
So if they are saying a clock signal, they are related flip flop.
Uh, and data also, sir.
Okay, data also. That
Yes.
means they are related flip flop.
Yes, sir.
Then the first and the third is also sharing a clock and the data. What does that mean then?
Global skews.
So you mean first and third is global skew. First and second is local skew.
Yes, sir.
Sure.
Yes, sir.
Then what do you mean by first and last? What will it be? first flip flop and the last flip flop?
It comes under also global skew.
So you just already said global skew for the first and third. First and last, how can it come under global skew again?
Side by side is only the local skew, I think.
Heard about launch and capture flip flops?
Yes, sir.
So now define skew before going for local and global.
Uh, the delay between clocks arrival of clock signal between two flip flops.
The delay between arrival of clock signal between two flip flop.
Yes, sir.
Which two flip flop?
Launch and capture flip.
So the between launch and capture flip flop, the arrival of the signal, that is what arrival of? What is it?
The arrival of clock signal between
Clock signal between launch and capture is called as skew.
the delay. Yes.
Okay. Now define local skew.
The delay the delay of clock signal between the launch and capture flip flop of related.
You
Sir,
are
I think,
mentioning related. You have to
sir,
tell me how they are related.
both are same as the launch and capture flip flop
Of what?
of the flip flop. Launch and capture flip flop. Launch and capture of the flip flops signals.
Not defining properly. I think you need to revise this. I understand this more clearly. So you don't know local skew, don't know global skew, will not touch
Sir,
it, touch it. Yes.
sir, local and global. Local means the two flip flops which were using the same clock signal.
Even the last flip flop in your design will use the same clock signal. There is no change in that. Every cell in your design will use the clock signal which is coming from the clock pin.
Yes.
So you have one clock, right? Assume you have one clock in your design. All of your design will use that clock signal only, right?
Yes.
Then how can you say that? Okay, will you tell everything of them as a local skew?
No, sir.
Then revise it. You don't know CDS. Uh, let's go to the route then. We'll go to route and we'll end this.
Yes.
So in route, assume I have a signal where where I'm having a signal between two cells.
Yes.
There's a net length. There is net going on. The net length is somewhere around 180 micron. Now what is happening is that I'm having a huge delay in that net length.
Yes, sir.
I mean, huge delay between those cells. So I have done all the things. Now, what can you do in with respect to the routing so that this delay gets reduced? This is causing
Sir,
a setup violation for me.
by pipelining techniques.
What do you mean by pipeline technique?
Uh, ch- Changing the position of flip flop.
No, I can't do that. I am talking only about the routing. Changing cells, this I can't do because that has
Okay.
already done in placement, right? I
Yes.
can't change any cell position. I'm asking about only the routing.
By adding buffers, sir.
Hmm?
By adding buffers.
No, that is ECO. I'm asking only in route.
Sir, here we can't do any timing driven placement or something. Timing driven route.
See, I'm not talking about
Routing.
the placement.
Okay, sir.
All I'm talking is that there is a net, okay,
Yes.
between a cell A and cell B. Both are
Yes.
standard cells now. So between these two cells, there is a net.
Yes, sir.
Okay, there is a routing happening, routing that has happened already.
Yes,
Now,
sir.
what will you do to make sure that this routing between these two, is right? These two, there's a routing. So
Yes.
there is a delay from cell A to cell B. There is a lot of delay between them. Okay, now I want to reduce this delay. I can't add a cell. I can't do anything else apart from by adding a cell or moving a cell. Only thing is I have to do something with respect to the routing. So
Yes,
what can I do with this? What can I do with the routing techniques, or what can I do with routing so that the delay between these two is going to reduce?
Jonas.
So you don't know routing also. So you were given a scripts, right? In your this thing, they used to give a script and you used to just source them, right? That is what you have
Yes.
done. So have you ever opened the script and studied it? Seen what commands are there, how they go,
Yes,
what
sir.
do they
But
do?
it's already 3 months is over, sir. So some more times.
How can I hire you if you are 3 months? If you're forgetting everything in 3 months, how can I hire you?
Yes.
Hmm? How can I hire you? So you are saying that it's already 3 months means that's an excuse you are giving. That's it. Even
I'll go
after
with
30 years, you need to remember, right? How will you sustain in the industry if you are forgetting everything just after 3 months?
I'll go through it, sir. And
Go through it. Study. First thing is you have to study well. There's a lot of things you need to cover. You are
okay, sir.
not clear with any of your answers. Okay,
Okay, sir.
fine. We'll end this mock.
Thank you, sir.
Okay,
Sir, this is my first interview, sir.
fine, fine.
Uh,
So it's need not to be that just because you are in first interview, you should not do well. There
yes.
are people cracking first interview very well and getting their job. So you need to be ready for everything. No excuses given. If you are
Okay,
giving
sir.
excuse, nobody takes you. That's the only way that the industry works. If you are giving
Yes.
interview excuses, nobody will take you. They'll say, no, fine. You get 15 interview experience. By that time, I'll take someone else and give him a job.
Okay,
Nobody
sir.
cares for your excuse. Nobody looks for the sympathy here.
Okay, sir.
That's how industry is working. Fine.
Yes.
Okay.
Yes.
Bye.
Bye, sir.